Hi there! In this video tutorial for Coherent UI, we're going to have a practical example of adding user interface in your game. We're going to use some resources from the internet, and we're also going to write some of our own. I've already prepared the resources needed for today's tutorial on the desktop, so here they are. I'm going to use the Unity project Stealth as a base of our demo, and the Coherent UI 152 standard package for Coherent UI. I'm also going to use the jQuery JavaScript library and the Coherent UI JavaScript library. And these two are the resources from the internet that I talked about, which you're going to be seeing shortly. So, let's get going. I've already imported the Project Stealth package and Coherent UI, and I also installed Coherent UI using the Install Coherent UI option. So, let's get started by adding a Coherent UI view to the camera. We're going to be using local resources, so we need to use our special protocol named CoUI and UI resources, which is the default folder for UI resources, Stealth, which is a directory that I'm going to be creating shortly, and the first element that I'm going to add is a help bar, so I'm just going to call it health.html. I also want this page to be transparent, so I'm just clicking the is transparent option. Okay, so let's find the UI resources. They are in the root of your Unity project. I'm going to create a Stealth directory here, and inside the Stealth directory I'm going to extract the first resource from the internet. First resource is a progress bar that is going to be acting as a help bar. This is just a random CSS3 progress bar search from the internet. It's probably the first hit, so this is the URL. All these resources will be available in the description of the video, so don't worry about it. Just you can download it. I've already downloaded the progress bars. So these are the files. I'm just gonna copy paste them here and close this. So we named our HTML file health, so I'm going to name this health, and let's see the CSS. We're going to be using some more CSS files, so this will be health CSS. Now let's see this in the browser, so that's what we got initially. Let's just check it out. Okay, so first we need to rename this to health. I'm going to remove this because I don't need it, and I'm also going to use the local JavaScript file instead of the local jQuery file instead of this one. So let's say JS jQuery jQuery-2.03.min.js, and I'm also going to move these styles from here to the CSS file, which is right here, Stealth health CSS. As you can see, these are just some CSS rules for the body, for h1 and pre. We don't need all of these. Actually, we don't need any of this, so I'm just going to delete that and add the styles that were in line. So let's see what we got. We have the same thing. That's great. So I like this progress bar, so I'm just gonna leave that. And that's this meter. So I'm gonna delete everything else, and I'm gonna add it. So let's see what we have. Great. But our health is going to be full initially, so I'm going to change this to 100%, and that's it. So let's see if we have any errors. Yes, we do, so we need to fix them. There, we don't have jQuery. I forgot to copy that. So I'm going to make a new folder, JS, and I'm just going to copy both these files here. Let's see now. There's the animation. Okay, so in the CSS file, let's do some more positioning. So we want the meter to be absolutely positioned, and I'm gonna have it in the lower left corner, so I'm gonna say left, say 30 pixels, and bottom again 30 pixels. Let's see how this goes. It didn't go well. Oh yeah, I need a width, say 200 pixels. And there it is, our health bar. So that's pretty much it. We've modified the health bar to our needs, and let's see how it goes in our game. We have the component, the URL is correct, so let's hit play. And there it is. Since we're going to add better UI than the current one, we're just going to disable these GUI text components so they don't interfere with our new interface. And there it is again. So now we're going to add a function that changes the health, because we want to bind that to the health of our player. So this animation function animates the health bar when document loads, so it's pretty much what we need. We're just gonna copy paste that, and I'm gonna make that a named function so we can pass that to Coherent UI. We can bind it. Actually, we can bind it if it's an unnamed function as well, but we can test it in Chrome better. So I'm gonna change that to a function change HP, and I want percent as an argument. So this thing here is the data that we'll be passing to animate, and I'm gonna call it target width. So here is the property that we're going to take, target width, and the time to animate that, and let's make that half of the animation when we are starting, so that's 600 milliseconds. The width, the initial width, is going to be this dot width, which is the current width. We want to animate the current width to the target width, and the target width is going to be percent times 0.01 times the width of the container, not the current width, because the current width might be, say, 50%, and then we're going to be animating something really weird. So this parent width, and we don't need this, so let's just test what we have. Go to the console, say change HP 30, and there it is. But if we say 130, it's going to be out of bounds. So let's add a simple check for the percentage. So if percent is less than 0, percent equals 0, and if percent is greater than 100, percent equals 100. Let's check it out again. Oops. Go to the console, change HP 30, 40, 140, minus 140, and there, it looks great. So let's check it out in the game. It works fine. Now we want to bind that to a function, so a function called from C#. So let's just add the Coherent UI script, which is text JavaScript source is js/coherent.js, and we just want to bind a function that we'll call this change HP function. So what we do is use the engine object, on which the engine object is defined by Coherent.js. So when C# triggers the event change HP, we're going to call the change HP function. And that's pretty much it for the health HTML. So, oops, I got it one more time. So, let's add a new script. I'm gonna add all the new scripts here in the down folder. So I'm gonna call that player UI, and the player UI is going to be attached to the character, which is char eaten. So let's add it here, char eaten, and let's edit the script. First thing we need, of course, is a reference to the Coherent UI view, which I'm gonna call view underscore. We also need a reference to the done player health component, which notifies us about the health of the player health. And since we don't want to trigger events constantly, we want to cache the last health that we know about, and only if that value has changed, then we're going to trigger an event. So we need a new float, the last health, and we also need the maximum health, so we can compute the percentage. In the start method, we're gonna get the references for the components. This would be camera, main, get component, Coherent UI view, and since the player UI is attached to the same object that done player health is, we're just gonna say health equals get component done player health. We're gonna set the last health to health.health and the max health to the same value. We're just gonna need that for computation. So every frame we're gonna check if the last health that we know about is different from the health.health from the health component, and if it is, we're gonna trigger an event. View.trigger event change HP, and here we're gonna do health.health divided by max health multiplied by 100 to make that a percentage, and we're gonna save the value. Last health equals health.health. So the component is attached, I think. Yeah, it is. Oh, yeah, and we have a compilation error. Yeah, that compilation error is because trigger event is in another namespace, and we need to add using Coherent UI binding. So the component is attached, we don't have any more compilation errors, and when we hit play, the health bar is there. I'm gonna go to an enemy that can shoot me, and there it is, and I'm dead. So this eaten guy isn't very strong, so we're gonna add a bit more health so we can go and explore things. So let's make the health 1000 instead of 100. Let's see how that works. Go to the enemy, have him shoot us, and come on. Okay, everything works. So there it is, the health bar's done. And the next thing we want to do is add a radar. The radar is going to notify us where the enemy is. So I'm gonna name this the radar, and we're going to make another HTML. This another HTML is the radar library that I've taken from the internet, from this GitHub site, and I've already prepared it here, so I'm just gonna show it to you. It looks really cool, and you can add pins and they make sounds. So let's just close that, and I'm gonna copy that or I'm just gonna copy the needed files to our directory with the UI resources, and we want to merge those. So let's see what we have here. Let's just close the unnecessary windows. We don't need this anymore. Okay, so let's take a look at the radar. First and foremost, of course, let's rename this to radar HTML, and this main comes from the library. We're gonna name that radar CSS, and we don't need the reset CSS because we don't want that to reset our styles. It's needed if you're in a browser. So, oops, health. Let's open that, and we rename the CSS. So let's just get back to it. Reset, we don't have that. We don't need this. Actually, we don't need any of this. Radar CSS, and we don't need the font. So let's restart it, and there it is. So it's really good, but we don't need this header, and we don't need this information, and we also don't want that sidebar because we'll be triggering the nodes programmatically. So let's just remove some of these. Actually, we're going to remove the whole header. We don't need the header.js, and we don't need Google tracking. Let's see how this goes. Oh yeah, and we're going to remove this span. If we refresh that, everything's fine. So next thing we're gonna do is modify the JavaScript bit. It's right here in radar.js. So here in radar.js, I'm going to be adding some variables that are going to be accessible outside this JavaScript file. So I'm going to be adding the array for the nodes, and I'm going to call that game radar. And first, it's going to be an empty array. I'm also going to add a variable that says how many nodes do we want horizontally and vertically. That's going to be game radar width, and I'm going to go with 6. Var game radar height, and that's going to be 6 as well. And I'm going to copy paste these here and here. Of course, this is going to be the height, and I also want the size to be smaller. I'm going to go with 200, and the center will be the center of the rectangle, so that's going to be 100, 100. Next thing I want to do is save a reference to the array of nodes. So there they are, nodes, and I'm just gonna say game radar equals nodes. Let's see what we have so far. A little radar. That's superb. So now I want to position this radar, and I want to position that in the lower right corner. And I also don't want the mouse to be able to activate nodes. So, of course, I've already done a research of this radar.js file, and the mouse events are handled by this method, @eventListeners, which adds event listeners. So I'm just gonna comment it out, and the onWindow resize function actually positions the canvas in the center, and I don't want that because I want to do that in CSS. So here the left and top properties I'm going to comment out, and also this width accounts for the width of the sidebar, which we are not going to use. I'm sorry. So we're just gonna say container style width equals world width in pixels. So Let's check out this, and there it is. It's positioned in the top left corner. So we're gonna open the CSS file, radar CSS, and I'm just gonna delete some stuff that I don't need. Background, we don't need this background. We want it to be transparent. The container background and the box sizing we don't need. We also don't need any of the header CSS rules because we deleted the whole header. And there it is, the wrapper. The wrapper I'm going to position in the bottom right corner. So let's say bottom 30 pixels and right 30 pixels again. And we don't have this background, so I'm just gonna delete that. And while we're at it, I'm gonna make the canvas, this is the canvas rule, semi-transparent by using RGBA 000 sig 1.3. Let's refresh that, and there it is. Let's see if we have any errors. No, we don't. That's great. And so let's see how that looks in our game. We have that radar. And there it is. Now this radar has a bit of performance problems with the audio that it emits, so I'm just going to disable it for this test. And this is done in radar.js, which is one of these files. I'm just gonna search for play. Not this, yeah. So when one of the circles hits a node and it's activated, it plays a sound, but it's really bad for performance, so I'm gonna command that. And we're just gonna have a visual representation. So we have this positioned. Let's check out if the game radar variable works. So game radar 10 activate. This is an array of node objects that have methods for activation and deactivation. So let's see if this works. 10, yeah, there it is. And it emits a sound because I didn't refresh that. So let's do that again. Game radar 10 activate. There it is, no sound. And we can of course deactivate it using deactivate. So that's great, and everything seems to be working. So now what we need to do is wire up Coherent UI. We're going to be using two functions, one for deactivating nodes and one for activating nodes. So we're going to do that in, not here. We're going to do that in the HTML file, which is right here. And first I'm going to use I'm going to add the Coherent UI script, which is script type equals text slash JavaScript script. Source is JS slash coherent.js. And script. And now we're going to add some functions. Script type equals text slash JavaScript. Close the script. Script. Yeah. Okay, so let's add a function. Activate radar node by index. If the index is greater than 0, is greater or equal than 0, and the index is less than game radar width multiplied by game radar height, then we're good to go, and we say game radar, game radar index dot activate. And we're just gonna copy paste that and make a deactivate function. Deactivate. And one more thing we need to do is attach some events to these functions. So when C# triggers an event, it is going to activate or deactivate a node. And we do that by calling engine.on, and I'm just gonna take the names of the functions for the events, so they're going to be the same. And copy paste that, deactivate and deactivate. Let's refresh that and check out if our functions work. So activate radar node at 0. Activate at -10, it doesn't do anything, and deactivate works. So that's pretty much it. Our radar is done. Let's see how that works. It should still work. There it is. Now we need a component in C# that's going to tell the radar what position the enemy is on. So let's do enemy UI, and we're going to attach that to each enemy, which are these 3 robots. So select them and say add enemy UI, and now we need to edit that. The enemy UI script, of course, is going to have a reference to the Coherent UI view. Say view underscore. It also needs a game object that's going to be a reference to the player, so we can compute the distance. It's going to be private game object player. And again, we don't want to be constantly triggering events, so we're going to save the last position of the last index in the nodes array of the enemy, and we're going to check each frame whether it has changed. So let's add private int last index, and we're going to add the new index as well. New index. So let's get the references to our components, which will be view equals camera dot main dot get component Coherent UI view, and the player will be game object find game object with tag done tags player. The game object is tagged. The player object is tagged as player, so this is a very easy way to find out our object. And we're also going to set the last index to an invalid value. So next thing we're going to do is compute the index in the radar depending on the position of the player. So let's add a method for that. So it's going to be int compute index in radar. And for this example, I'm just going to hardcode some values, such as the radar width, which is going to be const float nodes x equals 6 and const float nodes y equals 6. But in a more real life scenario, you'd get those values from JavaScript instead of hard coding them. So next thing we're gonna need is actually a step that's going to be the actual distance between two nodes in the world. And I found out that a distance of, say, 3 is a nice distance. So we're gonna call that node's step, and it's gonna be 3 units in the world. So let's get going. First thing we're gonna need is the difference between the positions of the enemy game object and the player game object. So we say vector3 diff equals this.gameObject.transform.position minus player.transform.position. Okay, so now we want to see what's the difference in both in the x and y axis in nodes, not in world units but in nodes. So we're gonna do float offset x equals diff x divided by nodes x. And since the player is actually in the center of the radar, oops, yeah, we have compilation errors. Monodevelop. I'm just going to make this compile so I can show you the radar again, or let me just show you here. So the player is in the center, and the difference can be a negative or a positive number, but we have only positive numbers for the indices of the nodes array, so we need to offset this. So when the player is here and say the enemy is in the same position as the player, it's actually going to have an offset x of 2.5 nodes. It's actually the gap between the nodes that we're measuring, so it's 1 through 2.5. So for that to happen, we need to add another offset, which I'm going to call off x, and it's going to be a constant, which is actually the half the number of gaps in the horizontal direction, which is exactly nodes x minus 1 divided by 2. And I'm going to use the same thing for the other axis. And we also need to round that, so say mathf round this thing. And I'll just copy that and do the same for the z-axis. It's actually three-dimensional in the world, in the game world, so that's why we need z instead of y. Y is actually up. So we do the same formula, and we have the two offsets. Now we need to check if those offsets are actually in bounds. So say offset x is less than 0, or offset x is greater or equal than nodes x, or offset z is less than 0, or offset z is greater or equal than nodes y, then we need to return an invalid value, because this is outside the radar. Otherwise, we return nodes x times offset z plus offset x. And we need to cast that to an integer. And one more thing that I forgot to mention is that we need to negate the z difference, because in the game world, the z-axis is positive in this direction, while our nodes start here from 0, 1, 2, 3, 4, 5, 6, 7, 8, etc., 35. So they go downwards, while the z-axis is positive upwards, so we need to negate that. Now that the index computation is done, we actually need to make use of it. So in the update method of the enemy components, we're going to say new index equals compute index in radar. If the last index we know about is not the new index, then we need to do some stuff. Now, because we have multiple enemies, what we're gonna do is first deactivate all the nodes that they were on, and then activate all the new ones that they are currently on. So to do that, we'll also need another method that Unity conveniently provides, which is late update, and that is going to be executed after all the updates of all components. And here we're going to do pretty much the same thing. If the last index is not the new index, then we're going to trigger view.triggerEvent activate radar node new index, and the last index is going to become equal to the new index. And in here, in the update method, we're going to deactivate that. So deactivate and use last index. So that seems pretty much it. Oh yeah, and of course the trigger event error, we're going to correct it this time. Coherent UI .binding. So let's see what's going on in our game. Does it all compile? Node step, what? Node step is not used. Yeah, it's actually not used. Yeah, we don't need that. Currently, our step is 1 meter, which is fine. Not 1 meter, but 1 unit in the game world. So let's hit play. There are no enemies, and there is one that should be somewhere around here. He's here and back. There you can see it. Now he has detected us. There's one in front of us and one here. And it looks pretty nice. Let's see if the enemies come here. No. Let's make them see us, so there you go. And there's the enemy. The enemy AI is not the best thing in this game. So, the radar works. And that's pretty much about it. So, oh, we have some errors. Oh yeah, so this happens when Coherent UI is not ready for binding. So what we're gonna do is actually add another boolean, say private bool bindings ready, which is false initially. Or maybe initialize it where we initialize everything else for consistency. And in here we're gonna say view.listener.ready for bindings, and we're going to add a handler that does one thing, and this one thing is say bindings ready equals to true. And now before we trigger an event, we're going to check if the bindings are ready. So if we play, there are no more errors. There it is. We see the enemy moving, so it's triggering an event, and the radar is working. And there's another enemy. Okay. That's pretty much about it for the libraries that I'm going to use from the internet. And now what I want to do is add a simple alarm indicator that's going to tell the player if the enemy has detected the player or we are good to go. So I'm going to make another HTML file. I'm going to call that alarm HTML. I'm going to close these things that I don't need right now. And let's just copy that radar. I'm going to name that alarm. And I'm also going to be using some CSS styles. So I'm going to copy the radar CSS as well. So I'm going to call that alarm. And let's open that up with Xcode and clean up the old files that we're not going to need right now. Okay, so this is going to be alarm. I'm not gonna need any of this, maybe just Coherent JS, and I'm also going to be using jQuery, so I'm gonna add that. So type equals text JavaScript sources JS jQuery dash 2.03.main.js end of script. And this is not what we're going to be using, so I'm going to delete that. And I'm going to add a simple div that I'm going to call alarm, and it's going to be empty. So let's just add some animation in the CSS file. For the animation, I'm going to be doing a circle that's pulsing, and it's going to be green when the player is safe, and is going to change its color to red when the enemy has detected the player. So we're going to do this by using some borders I'm going to show right now. So let's go alarm, and position is going to be absolute, width say maybe 18 is good. Yeah, 18 pixels. Height is the same, 18 pixels. Left 30 I think was the health bar. Top 100 or maybe 50. Yeah, 50 pixels. And I'm gonna make a circle using border radius. So I'm gonna need a border which is going to be 16 pixels solid, and is going to be green. Yeah, green, because the player is not detected when the game starts. I'm gonna need the background color, which is going to be the same as the border. And I'm gonna add some animation right now. So WebKit animation name equals circle pulse. I'm gonna add that later. And since Coherent UI uses WebKit as the layout engine, we're going to be using this WebKit animation name CSS rules. But it's still a good practice to make your CSS files layout engine independent, so you can test this in non-WebKit browsers such as Firefox. So let's continue with WebKit. Yeah, actually this is one important thing that I forgot, is WebKit border radius, which is going to be 30 pixels, about 2 times the border. I think it's going to be looking fine. We're going to test that in a minute. So let's finish the animation. Animation duration is going to be 1 second for starters. And WebKit animation timing function I want is out, and the WebKit animation iteration count is going to be infinite. I think I specified all the properties for using WebKit animation by itself, but anyway. So now let's define the keyframes. WebKit dash keyframes circle pulse. So in the beginning, I want this to be transparent, completely transparent and small. Then it's gonna grow, it's gonna be completely opaque, and in the end it's going to be transparent again. So let's do that with 0% at the start. We want WebKit transform, say, scale to 10% on both axes, and the opacity will be 0. And I also need to add the opacity here, because otherwise it's going to be very abrupt change. It's going to be a very abrupt change. So opacity 0. And in the middle of the animation, I want that to be completely opaque. So opacity 1. And in the end of the animation, WebKit transform, I want that to be big, so I'm gonna say scale 1.0 or even 1.2, and the opacity will be 0 again. So let's check out what we just did. Let's check it out in Chrome, and there it is, a pulsing circle. Now we need a function that changes its color. So that's pretty easy. We just go function change alarm color, and that's gonna be we're gonna use jQuery to get the alarm dot CSS background color. Oh yeah, and we also need to change the border color. So I'm gonna do this border color equals color. And while we're at it, let's just wire the events. We're gonna say engine dot on change alarm color, and we're gonna call change alarm color. Let's just test that. Go to the console and say change alarm color, and we want that to become red. So F00, and there it is, it's red. Okay, so this is pretty much done. Let's see if it works in our game. There's a circle, it's green, and currently there's nobody to change it to red. So what we're gonna do is add another component, which I'm gonna say, let's call it alarm indicator UI. Yeah. And we're gonna attach that to the game controller. The game controller knows when the player is detected and when he's not. So this alarm indicator, let's just start with using Coherent UI binding. As always, it needs a reference to the Coherent UI view, and it also needs a reference to the component that tells us whether the player is detected or not, which is the done last player sighting component. So I'm gonna call that sighting. And of course we're gonna cache the last position that we know about for the player, so we don't trigger multiple events without need. We're gonna say private vector3 last position equals something. So in this component we have two positions: the current position, or the last position that the player was sighted, and the reset position. And the component tells us whether the player is detected or not by comparing the position to the reset position. If these two are equal, then the player is not detected, And if this is not the reset position, then the enemy knows that the player was somewhere around that position and he has been detected. So, not this. Let's initialize this to the same reset position that the done last player citing component uses. Get the references for our components. Again, camera.main.getComponent, Coherent UI view, and the citing is going to be, we've already attached the alarm indicator UI to the game controller, so we can just go get component from done last player citing. In the update method, this is what we're gonna do. If the citing position equals citing reset position, and the last position that this component knows about is not equal to the citing reset position, what this means is that this frame is exactly the moment that the player just went out of sight. That's because this part tells us that the player is safe or he's out of sight, and this part tells us that the previous frame he wasn't. So what we want to do here is do view.trigger event, and we're going to change the alarm color, change alarm color to green. So this is going to be 0F0. And else, if the citing, auto completion didn't work, oh yeah, I have an error. If citing still doesn't work, I'm just gonna copy paste that. So if the citing is not the citing reset position, which means that the player is detected, and the last position is equal to the reset position, this means that this frame the player was detected. So we do player was just spotted. We do view.trigger event, and again change alarm color to red, which is F00. And in the end, we update our position. So last position is equal to citing position. So let's see if that compiles. The component is attached, and if everything worked fine, we're going to see this circle turn red when we're detected. Yeah, it turned red. And let's see if we can fool the guard. And now we wait, and there it is, it went green. So that's the alarm indicator, and now what's left to do is combine the three components that we made, the help bar, the radar, and the alarm indicator, into one single HTML file. So that will be our heads-up display. Let's call that HUD.html, and I'm gonna copy that from the radar HTML and call it HUD. Now we're going to need this. Okay, let's close these. When combining multiple HTML files, sometimes you can go into some trouble, like CSS styles that overwrite each other. And for this example, we've taken precautions that this doesn't happen, but of course, if you do combine some other files, when you try this out, you can run into some problems, so this is not going to be a trivial process every time, just so you know. So the HUD, we need the HUD, which is the radar. The radar is already here. I'm gonna open up the health. We need this. It also uses jQuery and Coherent, so jQuery isn't in the radar. We're gonna paste that. There it is. And here in the custom scripts, I'm gonna make some sections for each widget. So this is the radar script section, and we need health bar scripts and also alarm indicator scripts. So the health bar adds these scripts, and it adds also this div. I'm gonna place it here. Health, and next I'm gonna merge the alarm HTML. It's very simple, so I'm just gonna paste the CSS style. Here's the alarm itself. It uses jQuery and Coherent. They are already here, and these are the scripts that the alarm uses. Let's just add those. And if everything went fine, now we should see the whole heads-up display in the game. So the URL is correct, and let's check out what we did. There's the health bar, there's the alarm indicator, and there's the radar. And now we're detected. There should be some enemies right here which are shooting us, and the health is going down. So that's great, everything worked fine. Well, that's for this tutorial. I hope you found it interesting and useful. Of course, stay tuned for more, and thanks for watching.